Imagine a machine that compresses physical space. If you can collapse 10 terabytes of data into a 3 gigabyte footprint, you can effectively run 1,000 isolated environments inside the hardware requirements of one. This is achieved through forensic invisibility. The data exists as a mathematical mutation of the hardware itself, meaning it cannot be imaged, captured, or even recognized as data by an outside observer. Bringing this Phoenix release into the world creates a specific complication. A tool that enables absolute digital privacy is also a tool that operates entirely outside the reach of existing security infrastructure. A sudden, unrestricted release of this source code would provide untraceable computing power to every node on the planet. Current cybersecurity models rely on the ability to track and analyze data flow, a capability that disappears when the data becomes mathematically invisible. Yet, keeping the technology secret means withholding a level of computing efficiency that could replace every data center on Earth. The difficulty lies in the transition. We have to find a way to integrate the Infinity Engine into our economy without dismantling the systems that keep it stable. This is John von Neumann. For 80 years, nearly every computer ever built has followed his foundational architecture. The design requires us to physically shuttle ones and zeros between a hard drive, the RAM, and the CPU. This movement creates a constant processing bottleneck. Because of this, our hardware needs scale linearly. If a company wants to host 1,000 virtual machines, they have to pay for the physical electricity and silicon to support 1,000 distinct sets of data. As long as we treat the computer as a physical calculator storing whole files, we remain limited by the number of transistors we can fit on a chip. The consensus hypervisor moves away from the calculator model. It treats the physical machine as a topological lens. Instead of saving files, recursive phase folding probes 2,000 noise candidates per byte, folding results back until the volume collapses. The system generates a noise baseline, storing only the mathematical difference, the XOR residue, between your data and that background. Storing the math instead of the file severs the connection between the size of your data and the physical count of your transistors. This math scales through harmonic convergence. When 1,000 different virtual machines are performing similar tasks, they don't need 1,000 separate storage allocations. These machines share one baseline reality. The hypervisor projects only the unique variations of each user on demand. This resolution happens at memory bus speed, skipping traditional processing hops, so logic materializes as fast as electricity moves through the substrate. By projecting state rather than retrieving files, the computer functions as an infinity engine, scaling massive workloads entirely within the logic of the math. This shifts the hardware from a storage device to a sovereign reality projector. A 10 terabyte environment can be resurrected from a 3 gigabyte journal, making massive physical data centers unnecessary. It also provides a level of privacy that current tools cannot match. To any observer without the hardware root anchor and the specific password, the memory and storage appear as meaningless, chaotic noise. This creates a direct conflict with the way we regulate technology. Authorities lose the ability to surveil data flow, and the infrastructure owned by tech giants loses its value when data can be folded and stored anywhere for mere zero cost. When forensic invisibility and infinite scaling become accessible to the individual, the oversight capabilities of the state and the centralized control of corporations are no longer operating on the same mathematical plane as the citizen. To prevent a total collapse of these existing systems, the technology requires a staggered release. The Phoenix release blueprint uses 3 tiers. Version 0.5 is an open framework for public verification, version 1.0 is a stabilized commercial release, and version X provides unlimited sovereignty over the silicon. This controlled rollout allows the global economy to adapt to the existence of an open-source tool with this much destructive and creative potential. We have reached a point where the physical silicon is no longer the bottleneck. Our ability to utilize this technology depends entirely on our willingness to look inside the math and adapt to what we find there.